Alright, so this is problem 7. Problem 7 reads, the local extrema of f of x equal x minus 4 squared divided by x occur at which of the following x values? So we have a local min at what x value and a local max at what x value. Now, in order to find the local min and max, we need to take the first derivative and use the first derivative test to find our critical numbers. And then once we do that, we'll use test points to see at what intervals it's increasing and what intervals it's decreasing. If you have an interval that goes from increasing and then to decreasing, so let's say a 5 was our critical number and we get increasing to decreasing, then we know that at this x value, x equals 5, there is a maximum. Because in order for it to go to increase to decrease, we need a max point there. Okay? So let's go ahead and take the first derivative and do the first derivative test. So f prime then. So as our function, we're taking the derivative of this. I'll use the quotient rule. So take the derivative of the top, that's 2x minus 4 times just the bottom. The derivative of x minus 4 is 1, so I'm not putting that. And then minus, take the derivative of the bottom, so that's 1 times just the top. And then divide that by the bottom function squared. So squared. So calculus is done. Now we'll just do some algebra and simplify this. Go ahead and x minus 4 and x minus 4 is here, common term. Factor it out. So we're left with x minus 4. Then on the inside we're left with 2x minus 1 more x minus 4. So we factored out 1, but there's 2 here, so there's 1 left over. Alright, so we have that divided by x squared. Alright. Now we have f prime x. Okay, so 2x, distribute this minus, right? So minus x, so 2x minus x is just an x, and minus and minus is just a 4, plus 4. So we have x minus 4 and x plus 4 divided by x squared. Alright, so this is the first derivative. Alright, we'll be using the first derivative for evaluating our test points. Okay, so we want to find the possible critical numbers. So in order to find the possible critical numbers, we have to make the numerator equal to 0 and the denominator equal to 0. Why the numerator equal to 0? Because that's when the function will equal 0. And the denominator equal to 0 because that's when it makes the function undefined. So, possible critical numbers. So we'll make the top 4 equal to 0, and we'll make the bottom equal to 0. Okay, when we do that, we get here that x equals 4, x minus 4 equals 0, that means x equals 4, and here we get that x is equal to minus 4. Set this equal to 0, move 4 over, you get x equal to negative 4. So these are possible, and also here we get x equals 0. So all these three numbers that we have here are possible critical numbers. To determine if there are actual critical numbers, we must go back to the original equation, back to the original function, and see if these x values are defined here. So for example, 4 minus 4 is 0, 0 squared divided by 4, that's defined, so 4 is fine. So 4 is a critical number. Minus 4, minus 4 minus 4, minus 8 squared, 64, and 64 divided by negative 4, that's defined, that's a number, that's a critical number. But 0 cannot be plugged in here because we get undefined for the original function. So x equals 0 is not a critical number. However, when we go ahead and draw it on our number line, we have, like for example, what I'm about to do now. So this is a number line, this is for f prime. When I go ahead and plug in my critical numbers in here, so I'll plug in negative 4 and 4, I'll also plug in 0, but note that 0 is not a critical number. The only reason why I'm plugging in 0 here is because at 0, the function is undefined. Okay? So once we have this number line here, we'll go ahead and pick test points. So I'll pick minus 5 from the left of minus 4. I'll pick negative 1 between negative 4 and 0. I'll pick 1 between 0 and 4. And I'll pick 5 to the right of 4. Okay, so now that I have these test points here, the test points get plugged into the first derivative. So test points do not get plugged into the original function. So remember, test points get plugged into first derivative. Okay, so plug in these test points into the first derivative, and what we're looking for here is not the actual number, just the sign, if it's plus or minus. Alright, so plug in minus 5 in here. We get minus 5 minus 4, that's a negative number. Minus 5 plus 4, that's a negative number. So you have a negative times a negative is a positive. And down here, this x squared, this number will always be positive. So you have a positive divided by positive. So positive divided by positive number. Alright, positive number means it's increasing. So from negative infinity to negative 4, the function is increasing. Okay, so now f prime of the next test point, 1, so negative 1. Negative 1 minus 4, negative number. Negative 1 plus 4, positive number. So negative times a positive, negative number. Now you have negative 1 squared. Like I said, this will always be positive. So we had a negative times a positive, that's a negative, divided by a positive is a negative. So negative divided by a positive is a negative number. Alright, so we have a negative number. That means that from negative 4 to 0, the function is decreasing. Okay? So now f prime of 1. Okay, so 1. Plug 1 back in here. 1 minus 4, negative number. 1 plus 4, positive number. Negative times positive is negative, and now it's positive. So we have, again, negative divided by positive, negative number. So then from 0 to 4, it's also decreasing. Okay, now let's try f prime of 5. Okay, so f prime of 5. What's f prime of 5? Plug it in here, that's positive, positive, and positive. So we have a positive number divided by a positive number, that's a positive number. So that's increasing. So from 4 to infinity, it's increasing. So what do we have here? In order for it to increase and then decrease, the function must be doing something like this. So there's a maximum here at negative 4. And in order for it to decrease and then increase, the function must do something like this, and there must be a minimum there. Okay, so then, local min at x equals 4, and a local max at x equals negative 4. So that's it. Now, if they wanted you to evaluate the actual local min and local max values, all you have to do is plug in these x values back into the original equation to see what the corresponding y value is for each of those x values. So that's pretty much it, and that'll be your answer.